Hello and welcome to air conditioning for the Airbus A320 family. This air conditioning part is going to be broken up into 4 sessions. Session 1 is overview and controls and indications, as well as a bite test. So we'll go over that. Session 2 is going to be on the cabin and cockpit, including pressurization. Session 3 is the avionics compartment, and Session 4 the aft cargo compartment and all the related systems there with cooling. So as far as the overview, we'll start with Session 1. The air conditioning system. Okay, think about 2 concepts or functions: cooling and pressurization, because that's what the air conditioning system is involving. So there's different subsystems, but as a general overview, just think of 2 different ideas, and that's the cooling of bleed air coming from the pneumatic system, and then you have pressurization of the fuselage. The areas that are affected, okay, by the air conditioning system is going to be your cabin and cockpit, and that's broken up into 3 zones. You have 2 zones in the cabin, that would be your forward and your aft, and then you have the cockpit zone. Number 2 is going to be your avionics compartment, because all that equipment generates a lot of heat, so we need to make sure we have a cooling system in that area. And this is tied also with skin temperature, okay, the airplane skin. So we're going to kind of put that together with the avionics equipment, cooling, ventilation, etc. And then the other area that's affected is the aft cargo compartment, and there's also ventilation there as well as heating in that area. The source of power for the air conditioning system is the pneumatic sources from the main engines, the APU, and also high pressure ground supply. Okay, so let's first talk about cooling, and then I'll move on to the pressurization concept. Here, the cooling, we're talking about cool air, because you know the bleed air that's coming from the main engines is just not practical at all in itself, right? Because it's extremely hot. So there has to be a system to cool that air so that it can be usable. So we have this. The cooled air from the cooling system is actually then being distributed, okay, after it's being mixed, and I'll get into that in a bit, but it's distributed by 2 air conditioning packs, okay? And those packs are, that outflow is going to the categories I mentioned: your cabin and your cockpit, and the avionics and the aft cargo compartments. Okay, so the cooled air source for the avionics and the aft cargo compartments are coming from the cooled air from the cockpit, okay, and cooled air from the cabin, respectively, which gets redirected and supplied through the cockpit floor. So when I'm talking about that, I meant the aft cargo compartment is getting its source of air from the cabin air. Okay, just so I can make that clear to you. The avionics is getting some of that air from the cockpit air. And then we'll talk about the ventilation system in the next, or in the appropriate session, when we talk about the ventilation, because part of the job of the avionics equipment ventilation system is to also cool the instrument panel and some, like the circuit breaker panels, etc., that are in the cockpit. Okay, so there's that. And then what if there's an emergency? What if we have both these packs just go kaput? Okay, because these 2 air conditioning packs are responsible for providing that good air, okay, that conditioned, proper air to those areas. What happens if they both fail? Okay, we have a backup. Okay, that would be the emergency ram air inlet. So if necessary, the pilot can actually operate that and get that in an on position, and that will open up the inlet. Avionics components, of course, need to be cooled. It generates a lot of heat, so that can pose a threat in itself. There's a temperature control for that avionics compartment area through the ventilation system. Okay, and then we're going to be looking at also some of that skin temperature input in conjunction with that. There's the aft cargo compartment that needs ventilation as well as heating, so that's actually going to come from the hot trim air that's mixed with the cockpit air. And then for the cabin and the cockpit, it's to cool the air, obviously, as well as the instrument panels, remember I mentioned before. And there's specifically placed vents that are allowing that air, that ventilated air, to hit the instrument panels to cool that area. Okay, and of course the cabin area for the comfort of the passengers as well. Okay, so what are we trying to protect? Okay, we talk about in Operation Aviation, we always kind of come from the standpoint of protection. We look at things from a security standpoint. So we're looking at the protection of equipment, which of course, down the line, it can obviously affect the safety of passengers and the flight crew. So here in the avionics compartment, we're talking about components that are here of interest, and that would be your transformer rectifiers, your rack, all your rack equipment, your window heat controllers, because also you have your zone controls. You got controllers in that avionics compartment on the racks. There's also cathode ray tubes that are located on the pilot's panel. Then you have the pedestal instruments, the radar, the batteries. Okay, so just to give you an idea of what we're trying to protect here with the ventilation system. And then the aft cargo compartment, that has its own temperature controller, and that temperature controller is located and installed on the 96 VU panel in the avionics compartment. Okay, that's on the 96 VU panel. Remember that. There are computers, of course, all over the place. The computers for controlling the ventilation for the avionics area, and then there's also another for the aft cargo compartment, as well as a computer for the temperature control to the 3 zones in the fuselage. Remember I mentioned 2 zones, forward and aft cabin, and then the 1 zone is the cockpit. So those are the 3 zones. The computer for that zone temp is called the zone controller. Okay, I mentioned that earlier, but I didn't get really into it. I just mentioned it. So zone controller is what's controlling the temperature that can be regulated. By the way, the control is separate for cabin and for cockpit, so they can, there's control that can be done separately for those. That zone controller is located on the 93 VU rack. So where's the temperature controller for the aft cargo compartment located or installed? It's 96 VU. And then what about the zone controller? That's located on the 93 VU in the avionics compartment. Okay, then there's the computer for the avionics ventilation system. That is located on shelf 88 on the rack 80 VU. Okay, those are your 80s. Okay, so that's why that's there. So they're giving you an orientation on location of controllers that we have, because we have computers, which are the controllers that are located in the avionics compartment. Okay, so let's think of, so now let's look at just kind of a brush stroke on the components that we're going to be talking about a little bit more in depth in the cooling system. So with the cooling system, there's 2 air conditioning packs, and each of those packs have controllers. So there's a lot of different components that are involved with these packs, and we'll get into that when we come to that session, but I'm just giving you a heads up that there's going to be a lot of different components being, participating in this entire cooling system. So basically the air conditioning packs are going to be cooling that bleed air. Okay, and then you also have, remember I said you have that single zone controller that controls the temperature in those zones that I mentioned, the cockpit and the forward and aft cabin. And then each of the air conditioning packs themselves have 2 pack controllers. Okay, they have 2. So, remember redundancy, right? We have redundant systems. So that's why there's 2. You got your primary and secondary. In case one goes kaput, you have another, as a backup. So that's the reason why you got 2. Those air conditioning packs are located in the belly fairing. All right. And then the zone controller, okay, that's controlling, that actually controls the 2 pack controllers. So you got one big main computer controlling, the 2 pack controllers. And that all that input that the zone controller is getting is going into the mixer unit as well as the byte, because the zone controller actually controls the byte. So I'll mention that a little bit later, but that zone controller is responsible for kind of running that byte. Okay, so the mixer unit, I know I mentioned that. What is a mixer unit? What are we mixing? Okay, this unit is mixing recirculated cabin air with fresh conditioned air from the packs. That's what it's doing. Okay. There's also a trim air system. So we got trim air, and that's supplying additional heating for the two temperature zones that are not requiring a high demand for coldest air. So that's what it's there. Now, the one that's demanding the coldest air is going to be controlled by the pack temperature control. All right, so that gives you just kind of a brushstroke, kind of a helicopter's view of the cooling system, and kind of just here and there, what kind of components we're going to be talking about in depth. Air conditioning packs, zone controller, pack controllers, mixer unit, and trim air system. Okay, so now what about the pressurization? Okay, that was the cooling system. The second concept is pressurization. So here we have a cabin pressurization, cabin pressure and monitoring system. That's a mouthful, isn't it? Okay, it's shortened. The abbreviation is CPCS. Just know that it's a monitoring system for the pressure. Okay, and obviously the pressurized area is going to be in the fuselage. We're talking about the cabin and the flight compartment. So what are the related components? With the pressurization, it's going to be your cabin pressure controllers. Okay, we have computers here. We also have the outflow valve, and then we have two safety valves, and of course we have the system faults and indications that are there for the monitoring, right? So okay, so that gives you an idea with what we're going to be dealing with on the air conditioning system. Okay, because the subsystems are simply, we're talking about conditioning the air, cooling, and then we're also talking about where's it going to be distributed to, so a distribution of it, right? Okay, and of course controlling and indicating. So now let's go ahead and move on to the controlling and indicating. So what do we have? There's two pages that you want to be aware of when it comes to the air conditioning system. That's going to be your ECAM bleed page. That's number one. Number two is your ECAM cond page. All right, so think about this. We're talking about the outflow coming from the air conditioning pack, so we want to monitor that flow volume, the pressure, the temperature so we're talking about supply ducts as well. We want to monitor all of that, the outlet temperatures coming from the packs and from the compressor in the air conditioning packs. Those are important as well. So those are the things I'm just letting you know that are going to be indicated. So we got pack flow outputs that have an off and on selection with the push button switches, the zone temperature selectors, okay, for those three temp zones, right? And then you also have a trim air system on off selection as well. So that's what the air conditioning page is about. And like I was saying, there's two pages. You got the ECAM bleed page and your ECAM cond page. All right. So what kind of push button switches do we have on the 30 VU panel in the cockpit? Well, we have packs 1 and 2, and you can see on the diagram, just one on one side, one on the other. Of course, you're going to have your engine 1, engine 2 bleed air buttons, but those are there as well. But specifically, I'm talking about what's pertaining to the air conditioning system. So you got packs 1 and 2. Controls the pack flow control valve. Okay, we'll get into valves a little later, but that's what it's doing. So when it's on, okay, and we're assuming there's enough bleed air to run this so that the valve can actually open, okay, then that's what's going to happen when you push the push button switch to on. Okay, it's going to open up that valve. Now, the only time it's going to actually shut it off automatically is if the fire button's pushed, or there's an engine start that's initiated for 30 seconds, then the valve's not going to open yet. If there's an overheat detection, then that's not, the valve's not going to open, or the ditching push button's on. Okay, so those are conditions where the valve will not open. But otherwise, it's gonna open when that push button switches on the on position. Now, be aware that when it's on, there is no illuminated light. There's no illumination on the push button. It's illuminated when it's off, and that illumination is in the color white. Okay, so push button switch off for the packs 1 and 2 are going to illuminate in the color white. And be aware, because it just depends on what the application or function is as to whether or not it's actually going to be on. An example I can think off the top of my head right now is the ram air one, because you would think that, okay, if it's pushed, if it's depressed, right, if it's depressed in, then the light's going to be off, right? You're not going to see any illumination. But that's not the case with the ram air. You depress that thing, there's a blue color that comes on, so blue light, so it's a different matter. So anyway, just kind of letting you know, just be aware of that. So you got you got also a pack flow selector. Okay, the zone selector, for forward cabin, aft cabin, and your cockpit. You also have a hot air push button. The hot air, okay, so if you have that on, let's just say, that's going to regulate the air in the hot air manifold. And it's going to regulate that with the hot air valve and also with the trim air pressure regulating valve, okay, in that hot air manifold. So, so what's happening here when that push button's on, if the temperature in the supply duct goes above 190.4 degrees Fahrenheit, and some of these, by the way, are indicated in degrees Celsius on the actual panel, so you may not see a degrees Fahrenheit. You're just going to see some of this just in Celsius. So just so you know, the conversion of 190.4 degrees Fahrenheit, that's 88 degrees Celsius. Okay, 88 degrees Celsius. So, so here's the thing. If the temperature goes above that, then the valve's going to close automatically. Okay. And of course, if the push button is pushed off, then the valve's going to close. Okay. And anytime, again, there's that temperature issue, the system's going to protect itself. There's also a ram air push button switch that obviously when you push it, it's going to open up the emergency ram air inlet. Okay, so that's what it will do. So remember I said about the color, that might be a test question, by the way, just hint, hint. But yeah, when I mentioned earlier about the ram air push button, when you push it in, and by the way, there's a guard on it, so you have to lift the guard and then depress the push button. Then when you do that, then a light will come on. Whereas in the other cases, if you depress it, there is no light. Okay, so ram air push button has its own light. When you push it in, it's a blue color, and that's what opens up the emergency ram air inlet. Okay. There's also, when you do that, there's going to be a ram air on. Okay, that's in quotations, ram air on. That's going to be displayed in green on the memo display. So that's the effect of putting the ram air push button into an on position. Also, it's once there's a differential pressure, okay, of the cabin pressure, and that becomes less than 1 psi, then the outflow valve is going to automatically open. Okay. All right, so let's kind of go over some things on the bleed page. I'm going to go into bleed page and also the cond page. So just kind of get you familiar with, because there's going to be some test questions coming from this. I mean, you need to know, what's not on the cond, what's not going to show up on it, what is going to show on a cond page. What can you expect? And the same thing with a bleed page. What can you expect there? What can you, what's there? So with here, and you can see on the diagram kind of way it's, what you see there is going to be the pack flow as far as positions. Okay, so if we were going to take this from breaking this up into the indications for temperature, the indication for positions, the indication for the kind of like quantity, if you will. So if we do it this way, which I'd like to do, I want to start with the temperatures. Okay, what kind of temperatures are going to be indicated on the bleed page? Okay, remember I mentioned earlier about the air conditioning packs, compressors, so you have those. So the pack compressor outlet temperature is going to be displayed. Okay, and that's going to show up in a green color in degrees Celsius. Okay, so you've got your pack compressor outlet, and you also have your pack outlet temperature. So those two are going to be indicating on the bleed page. All right, so then what about the position. When we talk about position, we're talking about valves. So we got the pack flow control valve. Okay, so as far as indicating position for that, whether it's open or closed or in transit or whatever, because there could be other conditions, because you can have a disagreement. So let's just say everything's fine. We've got well, let's just do this. We've got anything that's horizontal means it's fully closed. Okay, so horizontal lines mean that it's closed. Okay, and when you see a vertical line, it just means it's not closed. Doesn't mean that it's perfect, like everything's fine. It just means that it's just not closed. Because if you can have a vertical line that's amber. Okay, because it's not, because the pack flow control valve is not closed, but it's also not in agreement with its corresponding push button. So when you have that disagreement, that vertical line is going to illuminate in an amber color. Okay, the green vertical line is just indicating that it's not closed. But then you have a green horizontal line, that means it's completely closed. Okay, it's completely closed, green horizontal line. Okay, so remember what I said about just horizontal line means it's closed. Vertical line means it's not closed. To what degree? Well, that just depends. Okay, so you have that, and just again, I'm going to help you out with like in a handout, and also we're going to go through a review of some of this stuff. All right, so that's what you have as far as position. We're looking at, we're interested in the pack flow control valve position, and then we also have the pack bypass valve. Okay, so we have the pack flow control valve, and then we have the pack bypass valve position that's going to be indicated. And this particular display is an arc indicator. Okay, it's not a vertical line situation. It's actually an arc, and the arc is always green. It's going to show the position of the turbine bypass valve that's in the pack. Okay, and that position is going to range from fully closed to fully open. So the fully closed is C, to fully open is H for the designation. Okay, so those are your positions. We talked about temperature indications, and also the other position is going to be your ram air inlet position. Okay, so here's where things change a little bit. Okay, because we have the green. We're going to talk about something fully in flight. So a green vertical line indicates that the ram air inlet is fully open in flight. Okay, remember I said that the pack flow control valve position when it has a green vertical line indicates that it's not closed. It didn't say it was not fully closed, it's not closed. But when we talk about the ram air inlet position, that green vertical line is going to say that it means it's fully open in flight. Okay, now the opposite of that would be a green horizontal line. Okay, so 90 degrees from that, we have a fully closed position for the ram air inlet. Okay, its condition is fully closed. If there's an amber vertical line, that means it's fully open on the ground. And if you see an amber slanted line, whether it's in the ram air inlet position indicating or in the pack flow control valve position indicating, when you see that amber diagonal line, that just means that the valve is in transit. In the case with the ram air inlet, it means ram air inlet is in transit. Okay, so kind of giving you hopefully a better orientation of understanding the indications. Now that was what you can expect to see on the bleed page, on the ECAM bleed page. But what about the ECAM cond page? What can you expect to see here? Think about, we got the zone controller. That's a big one right there. So zone controller, you're going to have things related to that. The cabin fan, okay, the cabin fan, duct temperature, the aft cargo compartment, and related components are going to be indicating, on the cond page. Okay, so again, it's going to be indicating for things that are not quite right. So with a zone controller, remember I mentioned the zone controller has two, by the way, it has two computers, as well as the pack controllers is again backup. So the zone controller, if everything's running fine, then you're not going to see an indication at all on the cond page. But if there's a problem with the primary channel of the zone controller, then what's going to display on there in green is going to be the alternate mode, which is abbreviated ALTN. That's how it is on the display, ALTN mode. And let's just say that the primary and the secondary channel, fault exists. Then what kind of words are you going to see? Okay, you're going to see the word pack reg, or the phrase pack reg. That's going to be in green as well. Okay, so along with the zone controller, as we're talking about zones, we're going to be looking, it's going to show any problems with zone temperature and zone duct temperature as well. Okay, so there's the zone duct temperature. Obviously, we don't want to go past a certain threshold on the heat, right? We are on the temperature. We don't want it to be too hot. So if it does go past that threshold, then that indication is obviously going to be in the amber color. But that's what you'll see on that con page is an indication if there's something, wrong. It's going to show for the zone duct temperature as well as for the zone temperature. Okay. All right, and so the other thing that's going to show is a cabin fan fault indication. And if there's a problem there, it's going to just read fan, and that's going to be in the amber color, obviously. The other areas that the con page is going to show indication for is going to be the aft cargo compartment related issues. That would be the conditions of temperature and also the valves. So remember the aft cargo compartment is going to involve the trim air, hot air valve, and also your isolation valve. We'll talk about all that when we get to the aft cargo compartment session and talk about its own ventilation, heating system. But for now, just know that there are valves related to the aft cargo section, and it's the trim air valve, your hot air valve, your inlet isolation valve, okay, and also your compartment duct inlet temperature. So you want to, that's important also that it doesn't go past a certain threshold, and if it does, then that's going to show up on that con page. Okay, so I'm just giving you an idea of what kinds of things you're going to see on there on the con page. All right, so that gives you an idea with that. Some of the other things you might see, or that you could possibly see anyway, is going to be, of course, I mentioned the temperature, so that's going to be there as well for that. All right, so that completes as far as orientation with what's on the con page, what's on the bleed page, what can you expect there. So now let's kind of go over the bite test. There's not a whole lot to this. Bites are bites, right? I mean, it's going to just do its check, kind of run automatically, and if there's indications of fault, then it's going to let you know that on the display. So let's go ahead and go to that. Remember, our main thing is our zone controller, because that's kind of running, the built-in test equipment function for, the temperature control system. So it's going to monitor both the hardware and the software for it, and it's going to send that data. If there's any failures, it's going to send that to the CFDS. Okay, so what kind of tests are there here? There's 3 tests that are involved. We got the system test, there's the continuous monitoring, and the power up test. So, the system test, that's just done upon request on the multi-purpose control display in your MICDO. Okay, so that's the request there for running that system test, and typically that's actually done, which makes sense, after you've replaced a part. So you want to do it before you replace a component, and then you want to obviously run a system check. You guys know that. That's standard procedure. Okay, so that you run that. You don't want to. That system test continues for not more than 300 seconds, just to give you an idea on that. And then the monitoring is a continuous monitoring. After you have power that is supplied to the system, it's going to constantly be checking for faults. So if it actually detects something, then the system's going to activate. Okay, it activates the backup, and that's going to discriminate which line, which LRU is messed up. Okay, so what about power up test? Okay, so that's the third test involved. The power up test, if the aircraft is on the ground and we're assuming that valves are closed, packs are switched off, okay, and you have your pack controllers that are energized and having finished up their power up tests for about a 5-second delay, then you're going to have the zone controller power up test that's done. And you're going to do it after a reset, okay, or after there's a power supply interrupt, how do you define that? It's going to be a loss of power for about 2 milliseconds, or after a cold start. Okay, so duration, what's the duration of the power up test? It's about 36 seconds. Now what happens during this test? Okay, it's going to start initializing the devices inside. It's going to check the hardware, the software. It's also going to show some things on the con page, so don't freak out. Things might go kind of, all over the place a little bit. It depends on the configuration of the aircraft as to what actually would be showing up on there while this test is going on. So, maybe you worked on one Airbus and it looked a certain way when you were doing power up, but then in another one it looked different. That would make sense, but definitely check with your AMM. But be aware that would be a legitimate reason why you may see some other things going on the display. So what you'll see for sure on that display unit, you're going to see the 3 trim air valve symbols that are going to move from cool to hot and from hot to cool. Okay, because it's just running that power up test. Now let's suppose that everything passes. Okay, the power up test, that it didn't detect any faults. Then the con page is going to look normal after all of that. If it finds a fault, because that's if it passed, but let's suppose that there was a fault that was detected, something was wrong, then the master caution light's definitely going to come on. And then you're going to have on the upper ECAM display, you're going to see a warning, because that's where all the warnings are, right? Of the con zone regul. The fault comes on. So it's a con zone regul fault comes on. So you'll see that as a display. Also, what you're going to see is an amber XX in place of the temperature indications. Those are going to come on as well. Okay. If you need to reset the zone controller, you're going to reset the following. There's different circuit breakers that have to be opened for so many milliseconds. So just check with your AMM. Make sure that you're, resetting the correct circuit breakers. I don't want to mention what they are because, again, it may vary depending on the configuration. I just want you to make sure you refer to your AMM and follow the instructions at your MRO. But just so you know, you reset them through the circuit breakers. Okay. So that gives you an idea with the bite test. Okay, zone controller controls the built-in test equipment function for the temperature control system. It's monitoring, its hardware, software, and it's going through 3 different tests. Okay, you have a system test, the continuous monitoring, and lastly is the power up test. Okay, so gives you an idea with all of that. All right, so now that we've covered quite a bit, I want to cover some knowledge checks, and this is not exhaustive. Hate to disappoint you, but these are not all the questions. Okay, but we're gonna have a review, so don't panic. Okay, so session 1 on overview, controls and indications, and the bite. Here's some questions, just a handful of questions to give you an idea of the questions that you will see on the test. Okay, so number 1, which display pages show the zone temperature changes? Is it the ECAM bleed page and cruise page, or is it the ECAM cond page or cruise page? Okay, it's the ECAM cond page or cruise page. What are the 3 temperature zones? Okay, here's your choice number 1. Aft cabin, forward cabin, and cockpit. or aft cargo compartment, avionics compartment, and cockpit? Okay, it's the first answer. Remember I said forward and aft cabin are two zones in the cabin, and then you have and the cabin, and then you have the cockpit. Okay, number 3. The ECAM system bleed page shows pack indications and faults. Is that true or false? Okay, that's actually true. Number 4, I didn't mention the temperature ranges, but I'm going to go ahead and give you the answer now. But the range of temperatures on the selector is for the zones is actually going to be 64.4 degrees Fahrenheit to 86 degrees Fahrenheit. So that's your range from cold to hot. Okay, for cold to warm is going to be 64.4 degrees Fahrenheit all the way up to 86 degrees Fahrenheit. Okay. Number 5, how many air conditioning packs are there? 2 or 3? You're right, that's 2. Okay. Number 6, the air conditioning packs are located in the belly fairing. Is that true or false? Okay, it's true. Okay, number 7, what is the backup air in the event that both air conditioning packs fail? Is it the alternate air conditioning pack or the emergency ram air? Okay, it's B, right? It's the emergency ram air. All right, so what would cause the fault part on the pack 1 or 2 push button? By the way, the buttons for the pack 1 or 2, didn't mention this, but they have actually the word fault on it besides off. So those actually could illuminate if there's a fault detected. Okay, so in what instance would that happen? Why would you have the light come on for the word fault on the actual push button? Is it from duct overheat or pack 1 or 2 overheat? Okay, it's the latter, right? Because we're talking about packs, so obviously, so it's going to be the pack overheat. Okay, so next question. When the hot air push button is depressed, this means it is now in the on position. Is that true or false? That's true. Okay, so when the hot air push button is depressed, the light of the push button goes off. Is that true or false? Okay, that's actually false. Remember what I said, if you depress it, the light comes on. Okay, what happens when the hot air valves close? Okay, number 1, the trim air valves close. Or number 2, the trim air valves open. Okay, I didn't talk too much about that, but it's one, one affects the other the same way. So when the hot air valves close, so do the trim air valves. Okay, next question. The ram air on. Okay, that is displayed where and in what color? Okay, 2 choices. Number 1, on the fault page in blue or on the memo display in green. Okay, that's the latter answer, on the memo display in green. Okay, next question. When the ram air push button is depressed, what color illuminates? Okay, is it blue color, or there is no color that illuminates? Okay, it's actually blue. The blue color comes on. Okay, regarding the pack flow selector, okay, this is going to be on the test, so just go ahead and make a note of this, take notes, because I didn't mention this earlier, but now you're getting it. But regarding the pack flow selector, it has a normal flow, okay, it has low to high. So what percentage of normal flow is the low selection? Okay, there's a normal selection, there's a low and a high. And so, your 2 choices are 50% of normal flow or 80% of normal flow. So just know it's 80%. Okay, so the low selection for pack flow selector is 80% of normal flow. Normal flow is 100%, right? Okay, incidentally, just so you have the knowledge, high is actually 120% of normal flow. All right, next question. The zone duct temperature is displayed on which page? Is it the ECAM cond page or on the ECAM bleed page? Okay, I mentioned things, I was talking about that. It's actually the ECAM cond page. Okay, that's where you're going to find that information on the zone duct temperature. Okay, next question. A green vertical line indicates that the ram air inlet, okay, this is ram air inlet, is fully open in flight or not closed. Okay. Okay, the answer is the first one. Remember I said when it comes to ram air inlet, that's when we're talking fully open in flight when you see the green vertical line. Now, what about a green vertical line? This is the next question. A green vertical line indicates that the pack flow control valve is, okay, choice number 1, fully open, or choice number 2, not closed. Okay, the answer is the latter. It means it's not closed. All right, so next question. An amber diagonal line indicates an in-transit action. Is that true or false? Okay, that's actually true. And that's true for the pack flow control valve indication, also the ram air. Okay, that's in transit. It's going to show that indication. Okay, next question. If the pack flow control valve is not closed and in disagreement with its corresponding push button, okay, so it's not closed and it's in disagreement with the push button, then what will the display show? Is it going to be an amber horizontal line or an amber vertical line? Okay, it's the latter. Remember I said vertical line means not closed. To what extent? Well, just leave it at that, but it means not closed. Okay, so that gives you an idea. There will be probably a few more. I don't want to inundate you, but I really want you to know it so you can impress somebody. But that gives you definitely a good foundation. So if you know these answers, you know, be happy, because that's a lot that you're going to see on the test. So, but I really wanted you to get more, just get it in your head and just know this stuff. Okay, so that concludes this session. But we're going to go ahead and move on to session 2. This is session 2 of air conditioning for the Airbus A320 family. Session 2 is on the cabin and basically fuselage air conditioning. So we're talking about the forward and aft cabin and also the cockpit. And also we're going to cover the pressurization and the components involved with the pressurization of the fuselage. So let's kind of start with an introduction into overview. I covered about how there are air conditioning packs. If you've been through Gen Fams before, of course you're going to have those packs. But we're going to go into detail on the different components that make up those air conditioning packs, as well as the zone controller. Zone controller is kind of the main controller receiving inputs that go to the pack controllers. So let's start with zone control, just kind of a review. The zone controller is located in the avionics compartment, okay, and that is just going to control the temperature for the cockpit and the cabin, and can be operated separately as far as being able to manipulate and control the temperature in each of those, those zones. It also is going to be receiving input, okay, from different temperature sensors, so I'll cover some of those. But that's what it does. It's receiving those inputs, and then it's going to be sending, an output to the pack controllers. Okay, so each air conditioning pack, which there's 2, by the way, right? There's 2 air conditioning packs. Each of those packs has its own pack controller. All right, so let's just suppose zone controller goes kaput. Okay, we have a failure of the zone controller, which, by the way, has 2 computers. Okay, the zone controller has a primary and a secondary. Okay, I think I mentioned that before. But, if for some reason the zone controller doesn't work, then the pack controllers are going to take over. All right. So just know that the zone controller is is there for that reason. And it's just going to make sure that there's a good pack flow from the packs. Okay. So, just kind of give you some of the functions of the zone controller. It is trying to maintain that constant desired temperature. Okay, so whatever that input is from the cockpit, from the pilot, it's going to be comparing that with what the actual temperature is, right? Makes sense. And then it's going to be doing everything it can to, make sure that that matches. It has internal, an internal testing. So it's like it has its own little nanoparticles, if you will, because it fixes itself, and it does its own test. It's also going to give to the FADIC the bleed air valve status. So that's the kind of information that it's getting and giving, to the pilot in the cockpit. It's going to give byte information on the wing anti-ice system, also for the PCs. Okay, so that's for the pack controllers as well, and any byte information, of course, on itself, on the zone controller. It's also going to perform an overheat detection and corrective action, because remember I said it's going to kind of correct it. It's going to do its thing to fix itself. It's going to be also there to calibrate, to deliver information to the CRT displays. Okay, so that's what you have. And just to give you an idea on the different kinds of, or different temperature sensors, remember I mentioned in general you have some at the mixer unit, and you also have a lot of temperature sensors within, the ducts. Okay, not just the duct temperature sensors, because you have those as well, but you have temperature sensors, for those zones. And those are located, installed in the ducts, the supply ducts to the cockpit or to the cabin, whichever. Okay, so just kind of reiterating that those are where those are located, and those sensors are, sending that information to the zone controller. Okay, and so remember I mentioned there's two computers with a zone controller. There's a primary and the secondary computer. And the primary, if for some reason the primary goes down, the secondary is going to take over, but not at full capacity. It's going to be at a reduced level, but it will be able to at least, have kind of a, meet the minimum requirements as far as the demands to, until things can be fixed or replaced. All right. So just going to give you an idea with some of the other things that it's doing. I mentioned the functions, with sending information to the FADICs. But as far as, what does the primary computer do? What's its function? Okay, it's going to be controlling the temperature control, right? It's going to control the temperature to the selected temperature, based on the temperature selector. So that's the primary computer's in charge of that. And just being able to keep that zone temp at a constant temperature, which would be at 75.2 degrees Fahrenheit or 24 degrees Celsius. Some of the things on the panels are in Celsius, guys, so just so you know, heads up. This is a European manufactured craft. So it doesn't mean you don't ever have degrees Fahrenheit listed somewhere, but on displays, on some of them, it's just strictly on Celsius, so just be aware of that. But the secondary computer on the zone controller is responsible for keeping that constant temperature. Okay, primary is in charge of valve opening and closing, also failure analysis, your bytes. It's data handling, overheat detection, all of that type of stuff is the primary computer's in charge of, okay, and is responsible for. And the secondary can do the same thing as well. What it won't do, okay, is the flow demand optimization. That is something that the primary computer strictly does. Okay, and same thing with the trim modulating valve control. That's strictly the primary computer's job. I mentioned about the valve opening and closing. With the exception of the closing of a valve on the trim air pressure regulating valve, that's something that the secondary computer can actually do. So I'm just giving you, you don't have to memorize all this. I'm just sharing with you that, there's just some things that the primary computer does that the secondary computer is not going to do. But for the most part, the secondary computer is taking over most of the functions in the event that there's a failure of the primary. Okay, remember the zone controller is located on the 93 VU rack. I mentioned that before. but just kind of reiterating, it's good to know where things are located. Again, the idea here is not to be memorizing everything, but wouldn't it be nice to just kind of show your stuff and say, you know, I already know where the zone controller is located. Never seen an Airbus here, never worked on an Airbus, but I know it's on the 93 VU rack. Cool, right? Okay. So temperature sensors all over the place. Okay. So I'm not going to go into all of them. Just you know what sensors are. They're going to be located on the supply ducts. You know, and obviously they're sending signals to the zone controller. Okay. All right, so you have those, and of course the diagram can give you an idea what they look like. There are different kinds of configurations of sensors, but this one will give you an idea what's installed here in the ducts in this plane. Okay. All right, so you have that, and then let's kind of, you know, we've got I want to touch a little bit on a few other things because I really want to talk about the subcomponents of the air conditioning packs. Each of the packs has different components, and the components are going to be your air cycle machine. You got you got your primary heat exchanger. That's a big one. So you got a primary heat exchanger, your air cycle machine, your condenser reheater, and you have a water extractor. Okay, your high pressure water extractor. Okay, so those are what you have. So in case you get asked on a test, what's one of the major components of the air conditioning pack? You know, and you see the word condenser. Okay, that's going to be an answer. Okay, or primary heat exchanger, that's an answer too. Okay, water extractor, same thing. And of course, along the way, you're going to have downstream check valves. You're going to have these check valves that are going to be installed between the condensers and the mixture unit. And then you have also fan plenums. Those fan plenums are installed in the ram air system, and those are attached to the air cycle machines. Okay, the air cycle machines are there. There's an air cycle machine fan that's in a bypass, but it's still rotating, you know, by the expansion of the turbine air. So I'll describe a little bit more of that in a little bit. Okay, so let's just kind of go over pack control. Your air conditioning packs, I just described to you the components that we'll get into. But we also have, you know, pack control. So we have zone control for the zones, and we also have pack controllers for, you know, for each of the air conditioning packs. So, so what do we have here? Well, we have the controllers actually have two computers just like the zone controller. Okay, so that stays the same as far as that, because we want to have a backup, right? So you have your primary and secondary with the pack controllers. The pack controllers in particular are located in the avionics compartment, and that would be forward of the nose wheel well on 95 VU and 96 VU. Okay, you can get through that same area even for the zone controller through the access door 8011. Okay. All right, so just kind of a reminder, what's the function of the air conditioning packs? Okay, well, their job's to reduce the temperature of the bleed air from the pneumatic system, right? It's coming off the main engines or the APU. And then what's it going to do? Okay, it's going to be distributing that conditioned, cooled down air into the cabin. And it's also going to reduce any water that's in the hot bleed air. And this is where that, you know, we're going to get into the some of the components in that I just mentioned. Okay, so what makes up all of this, right? I mentioned the water extractor and all that. So let's talk about the primary heat exchanger. The primary heat exchanger is located between the plenum and the main heat exchanger in the ram air system. Okay, this is where the ram air flows through the heat exchangers, which of course you know what exchangers do is, you know, it's cooling that air. You have main heat exchangers, so just so we're clear, there's a difference between your primary and your main. So your main heat exchangers are located upstream of the primary heat exchangers. And so the main heat exchanger's job is to cool the hot air coming from the compressors of the air cycle machines. Okay, so let me just repeat that. Okay, here's the difference between the primary heat exchanger and the main heat exchangers. Okay, your main heat exchanger's job is to cool the hot air coming from the compressors of the air cycle machines. Okay, because what the air cycle machine is going to do, it's actually going to compress the air. By the way, the air cycle machine is located between the condensers and the plenums, but its job is to compress that air and expand it. And the fan plenums are attached to the air cycle machines, and all of this is installed in the ram air system. And then you also have the water extractor. Water extractor is removing water from the hot bleed air. That's what it's doing. You also have condensers. The condensers are taking that cold air from the turbine of the air cycle machine. That decreases the temp of the hot air from the reheater. Okay, so it's going to decrease the hot air temperature to less than its dew point. Is what it's happening. So when it gets, when that hot air temperature gets lower and lower and lower, it's going to be lower than its dew point, and then you're going to have water in that hot air that's going to condense. So that needs to be, that needs to be extracted. And so that's what that does. That water extractor is removing that water from the condensers. You also have the reheaters. I know I mentioned that a little bit earlier. Those are located between the main heat exchangers and the condensers. Okay, it's all playing a part in that whole system. Okay, so I'm just giving you an idea. You've got water extractor removing that from the condensers. Condensers are collecting that water in that hot air. And then you got your main heat exchangers, which are just cooling the air that's coming from the compressors of the air cycle machines. Okay, and you got your primary heat exchanger that's located between the plenum and the main heat exchanger. Okay, so a lot of different things there. And then just kind of giving you a general overview of that. Okay, and you can kind of see, there's a diagram that gives you an orientation on, the relationship between or amongst these different components with the reheater, kind of where your bypass valves, your packs, and kind of the flow of things, and then where the sensors are located as well. Okay, so with the air conditioning packs, each of them has a computer. Okay, those are your pack controllers, and the purpose of that is again to monitor that temperature as it's going. It's going to get distributed to the cabin. There's the two computers like I mentioned before, and the pack controllers are installed 95 VU, 96 VU, and they're going to be calculating and sending those signals back to the zone controller. So zone controller's sending signals because it's getting input from temperature sensors, and then it's sending that information to the pack controllers. Pack controllers are doing its thing, in picking up signals as well and relaying that information back to the zone controller. So it's kind of just symbiotic relationship going on between the zone controller and the pack controllers, but that's what's happening. And again, all these pack controllers, or the two pack controllers, your zone controller, the controllers have their own, it's just inherent. They have their own built-in equipment tests. They have their own bytes, and that's just a given. They also can control, send signals to the flow control valves, so they're controlling the flow control valves, and also the bypass valve, for the temperature control. All right, so that gives you an idea with the pack controllers. All right, so, and just so you know, I mentioned the flow control valves. I'll just mention these are located under the center fuselage. Okay, so they're at the air conditioning packs themselves, but they're under the center fuselage is where you'll find the flow control valves. If you needed to access for whatever, if you really need to access the flow control valves, remember you have one left, one right, because you have left air conditioning pack, you have your right air conditioning pack. So if you need to access the flow control valve, which is your 11 HB, then you're going to be removing panels 191 and 191 KB and 191 BB. That's on the left side. Right side is 192. So the number changes from 191 for left, 192 for right, and it's either it's KB and BB. Okay, and just know that there are some filters along the way. There's an ozone filter, just to be aware. Of course, in any system, as you well know, you've been around these systems, you're going to have filters. So just be aware that they're there. Okay. Okay, so about the flow control valves, just so you know the orientation, they are installed upstream of the air conditioning packs, and they're going to control the quantity of the air that's supplied from the pneumatic system to the air conditioning packs. So that's your go-between from the pneumatic system to the packs are these flow control valves. Okay, one each for each of the systems. So they're going to control that. And as far as from the the controls in the cockpit, the airflow is selected by the Pack 1 or Pack 2 push button switches. So when the pilot is selecting either one of those, that's what he's doing. He's controlling those flow control valves by doing that. Okay, you remember what I mentioned before, when you have a pack flow selector switch that's selected on the normal position, it's going to be 100% of normal airflow. Okay, if it's in the low position, okay, LO, then that's actually at 80% of the normal airflow. Okay, and if you do high, remember I mentioned this was a test question, by the way, an overview in our session 1 overview, but its high position is 120% of normal airflow. Okay, so that's what's happening when the push buttons are pushed, they're depressed, is they're affecting the flow control valves. Okay, and that quantity. And again, just a kind of a quick note on the ozone filter. Actually, there's two. They're located above the air conditioning packs, and this is going to be forward of the flow control valve. So, same area where you can access, like I mentioned before, the air conditioning packs. Okay. All right. So, and I covered with the water extractor. Get an idea what it looks like from the picture, but there's. And also the configuration of the ozone filter, because there are different kinds of filters, right? So just gives you an idea what this looks like in this particular case. And then, of course, the condenser and what that looks like and what's part of that. Okay, so remember I mentioned about the air cycle machine. The air cycle machine its main component is this rotating shaft. And on there you're going to have the compressor. Because remember I mentioned I mentioned about the compressor of the air cycle machine, right? So you have that there, and then you have a turbine, and of course you have a fan. So of course you got bearings and all that great stuff, right? But the shaft is going to rotate, and it's rotating on 2 bearings. You also have a double self-acting air thrust bearing that takes the axial thrust loads. So just so you know what bearings are involved there when you get to it, if you needed to, to look at that. So that's what you have there. You also have air that's going to get through so that it can cool the bearing, and then all that gets discharged into the ram airflow. So there's a system there just to make sure you got the cooling going on for those bearings. And of course you have some seals there just to prevent leakage, etc. And then you have the fan air from this air cycle machine that's going to be discharged through a nozzle, and that's just that's just a fact. And then the primary heat exchanger outlet is connected to the discharge ram airflow through a diffuser. There's the plenum diffuser. The other little aspect to the air cycle machine is it has a de-icing system. So that might be a test question. Just know, does it have a de-icing system? Yes, it does. Okay, so you have high pressure air that's coming from the compressor scroll through a duct, and then that circulates through the turbine outlet to prevent the ice formation. Okay, that's how that works. And as far as the air cycle machine, where you have one for, obviously one for each pack, you have the left one, which is 10 HM1, that's located above the 191 KB. Remember the same panel that acts as the air conditioning pack. This one is located above the panel, and then on the other side, it's above the 192 KB panel. Okay, then of course you have reheaters. The reheaters are installed between the main heat exchangers and the condensers. Okay, so Same area, right? Basically, all your components for air conditioning packs are located or being able to be. You can access those through those two panels I just mentioned. Your 191 kb, 190, for the left, and then 192 kb on the right, or BB on either side. So, but just know 191 left, 192 right, and most of your components you can access through that panel. And yeah, you can see the kind of the way it's laid out. I guess with the configuration of the air cycle machine, where the turbine inlet's located, your compressor inlet, your discharge, your fan housing, your turbine outlet. Okay, just kind of giving you just a visual on that. And of course, you do have, remember I said about the de-icing, so there is that anti-ice valve, and that's just used to stop that ice formation downstream of the turbine and in the condenser. Okay, so that's where we don't want to have that form, so we've got these anti-ice valves. Those are installed in the ducts to the turbines of the air cycle machines, and those are upstream of the primary heat exchangers. Okay. Now, if you were asked, okay, what's the normal position of the anti-ice valve? Well, its normal position is in a closed position. And so what triggers the anti-ice valve to open? Okay, it's going to be the sensors. We've got a delta P sensor, or two, okay, one for each. So we've got a delta P sensors of the anti-ice valve that you can find across the condensers. And they open if those sensors find across there's an unusual difference. There's pressure differential. If there's a pressure differential across the condensers, then the anti-ice valve is going to open. Okay, so let's suppose there's a loss of a pack controller. If there is, the anti-ice valves control the pack outlet temperature. So it's kind of interesting. We have a zone controller that's the main, controller, and if for some reason that fails, and that it has two computers on top of that. So let's just say that fails and we have pack controller. If for some reason there's a failure of the pack controller, the anti-ice valves are gonna take over controlling that outlet temperature. Because remember, it's the most important thing is what's coming out of it, right? Because that's what's going to, the cabin and cockpit. So that's what it's going to do. It's also going to adjust the quantity of that hot bleed air that's added to the air cycle machine outlets. And if you were to be asked, what's the constant, approximately, what's the constant temperature of the pack outlet? What would you say? Okay, and the answer is, 15 degrees Celsius, okay, or 59 degrees Fahrenheit. That's the equivalent. Okay, so that's the answer. The answer is for 15 degrees Celsius, or 59 degrees Fahrenheit. Okay. All right, so you got that. So now you know there's anti-ice valves. Also, there's a bypass valve I mentioned earlier. Those are installed in the ducts that are downstream of the primary exchangers. What they are doing is they're splitting that hot airflow between the air cycle machines and a bypass. Okay, and those are located, same area like I mentioned. Remember the 191, 192. Just remember the air conditioning packs and those two numbers. All right. Okay, so we've covered quite a bit in mentioning different components that make up the air conditioning packs. And then we covered the pack controllers, okay, what its function is. And we also have just some valves that we mentioned. Now I want to mention about the ram air inlet actuators. Okay, because you have that. I mentioned the flap actuators earlier. Maybe it was in session 1, but here you've got the air inlet flap actuators that open and close the ram air inlets. They're going to send a signal. They are actually receiving signals from the pack controllers as to whether to open or close. So, and those are installed on the ram air inlets, okay, and the fuselage belly fairing. So if you need to access these actuators, you will be doing so through same panels, 191 and 192, right? Okay, so definitely reinforcing which panels here to access for a lot of these different components. Okay, And you have sensors for pressure, because everything I mentioned to you up to this point was about temperature. These were temperature sensors, right, for temperature control, input into all that. Well, now there are pressure sensors, but they're pack inlet pressure sensors, not outlet inlet. Okay, and then we have outlets. So we got a pack inlet pressure sensor. It's going to sense the pressure of the bleed air that enters the air conditioning packs, right? That's what that means. And then they're sending a signal to the pack controllers. Okay, and that's going to affect the flow control valves. Okay, they're actually installed upstream of the flow control valves. Now, there's also a pack outlet pneumatic sensors or sensor. Those are installed on the condensers, and they're connected to the anti-ice valves. So let's just say that there's a pack controller that doesn't work. Then the pneumatic sensor is going to transmit the pressure to the applicable anti-ice valve. And if the pressure at a pneumatic temperature sensor increases or decreases, okay, there's your differential, then that's when that valve is going to open or close to maintain that pack outlet temperature. Okay, so it's using the pressure sensor to affect the temperature, affect the pressure at a temperature sensor so that it can maintain that outlet temperature at 15 degrees Celsius. Remember what I said, that air conditioning pack outlet temperature needs to be maintained around 15 degrees Celsius. Okay. All right, so I want to go over a little bit more on the sensors. I know I just briefly mentioned that we have sensors in the ducts, right, and also at the mixing unit, which we'll get into in just a little bit. But here you've got different ones. You've got the compressor discharge temperature sensor. You've got also one for the water extractor, when the bleed temperature. Okay, you got your pack discharge temperature sensor. So those are the different ones you have, as part of the pack. Okay. The other thing that you're going to have is the trim air system. Okay, so basically the pack temperature control, okay, that pack temperature control is only going to be for the demand for the coldest air. Okay, the other two zones are controlled by the zone controller. Okay, and they're going to receive additional heating from the trim air system. Okay, so the trim air system, is what? So that's just a mix of the trim air and of the mixed manifold air supply. Okay, so where does this trim air come from? Trim air is bled from the ducting. It's coming from the ducting between the flow control valve and the primary heat exchanger in each of the packs. Okay. And just kind of a note on pressure. So when we're talking about the trim air system, we've got a pressure. There's a check valve in there that's going to prevent the pack, to basically, we're going to have some pack flow when one of the packs is shut down. So the pressure is reduced to 4 psi in the trim pressure regulating valve. And that's just to minimize noise to the cabin. If there's an overheat condition, then that pressure is going to be reduced to 2 psi. Okay, so a little on the trim air pressure regulating valve. This here again it's regulating the pressure of the air that is supplied going to the trim air valves. So it's going to perform a system shut-off function, and the function of it is to act as a kind of on-off. It's an on-off valve. Okay, that's all it is, and it's regulating the downstream pressure to a 4 psi above cabin pressure. Okay, now just a quick note on where it's located. This is in the aft end of the forward cargo compartment. Okay, it's going to be near the mixing unit. We'll get into the mixing unit as far as just kind of describing it in a little bit. You got a trim air valve, kind of basic there. I'm going to go over what you probably already know. You got your trim air check valve as well. Again, same panels that I mentioned earlier that you can access this. All right. Okay, so now we're going to move on to the mixing unit. I know I've mentioned that several times already. You've got a kind of a couple of things to look at here. You got a mixing chamber and a distribution head. So if you look at the mixing unit itself, there's two sections of it. You've got one that's, again, the mixing chamber, and the other part is the distribution head. So what is this mixing? You know, we've talked about mixers before, just when we talk about inputs. For example, when we talk about the Boeing 737 systems, hydraulic or whatever, we tend to talk about mixers there. Here we're talking about the mixture of different air. So we got conditioned fresh air, and then it's mixing that with recirculated cabin air before it gets distributed. Okay, so that's what that mixing unit is. And the mixing chamber, okay, that I mentioned a bit ago, that's made up of a laminate, okay, with a metal flange. This is bonded to the top. And then you have a distribution head that's made out of aluminum that is connected to that same flange, and that's distributing that mixed air to the system supply ducts. And that's going to maintain or contain, the hot air that's supplying for, for the different for the cabin zones, your forward and aft cabin. You also have crossfeed ducts that are installed between the distribution head and the main supply ducts. You have that. You also have a backup flap that's installed in the duct. Okay, so you have that there. And that flap is just there. It makes sure that there's enough fresh air that's delivered to the cockpit in case, there's a failure of pack 1. So just so you know, that's what that flap is there for. It's electrically operated, for the record. Okay, so it's there as backup. It operates in the case of like 75.2 degrees Fahrenheit backup mode. Okay. Now, where is the mixing unit? Where can you find it? Mixing unit is installed under the cabin floor in front of frame 36. So that's what you'll find. It's under the cabin floor in front of frame 36. And you can get to it through forward cargo. There's some panels there, your 131 panels. Okay. All right, so that's the mixing unit. Okay, and so now let's kind of go over just kind of touch on some fans and then kind of ventilation of lab and galley, and then again talk a little bit more about. We'll get into cabin pressure as well, but I want to just cover some of the aspects of the fans, and then some of the filters, and basically distribution. Okay, some more about distribution. All right, so you have cabin recirculation fans. The fans are installed with the recirculation ducts. Okay, they're powered by a 3-phase 6-pole induction motor, so you have that configuration that drives a fan wheel. And then those fans are operating at what RPMs? Just so you can have that in the back pocket. But it's operating it continuously, just so you know. Roughly 7,700 RPM. Okay, and that's assuming obviously you have power. So yeah, at 7,700 RPMs is what those fans are running. There's also thermo switches that are installed inside the stators of those fans. If the temperature reaches a certain level, that would be at be kind of it's 320 degrees Fahrenheit. Okay, give or take 46.4. But if it reaches that, okay, it gets to 320 degrees Fahrenheit, then the thermo switches are going to isolate the electrical supply to the fans. Okay, you also have the vibration damper mountings, so it just helps with keeping it quieter when they're running, because that's a lot of RPMs going, and that's just going to prevent damage, because we don't want to have we don't want to have that reverb going on, and have that resonance going into the structure. So that's meant to prevent a lot of that possibility of damage to the aircraft structure. There's also arrows on the fan casing that's going to show the direction of the airflow through the fan and the direction that the impellers are rotating. So there are those markings. You also have overheat thermo switches. You also have the, you know, on the overhead ventilation panel, okay, the cab fan's push button switch in the cockpit, and that switch, you know, is supplying that electrical power through the circuit breakers to the relays, okay, in order to move those fans. Okay, so about the relays, because if there's an overheat, we have overheat thermo switches and they're operating, and so if the fans are if they're going up to 320 degrees Fahrenheit, then those thermo switches are going to remove the ground from the power relays, which is going to, you know, force the fans to stop, and then those fan fault relays are going to open. And when that happens, it's going to send the signal to the CFDS and also your ECAM system, and letting them know, hey, you know, it's an overheat issue. Okay. All right, so that gives you an idea there. And the ventilation, you know, if you can, there's a diagram kind of give you an idea with the ventilation panel in the cockpit, and it's a 22 VU is what the panel is in the cockpit, and just shows you your cabin fan switch, you know, off on. Got your blower and your extract on there as well. Alright, so with the mixer, you also have a mixer flap actuator. Operates, and that actuator is operating a flap in the cockpit supply port of the mixer. Okay, so just so you know that, you know, you have that knowledge that it is there. So what happens is the flap is actually going to change position, okay, based on the actuator movement, but that's going to happen with depressing or putting the switch pack to off. So for example, let's say that you, in the cockpit, you select the pack 1 to be an off. Then the flap changes the position, and it's going to connect the supply duct to pack 2 mixer chamber. Okay, so it allows one way or the other, it's going to get that air. But the function is just making sure that there's a good flow separation between the 2 packs, okay, and that there's just fresh air quantity that's going on there when one of them is off. And of course, where's it located? The actuator is left of the mixer and the aft end of the forward cargo. Okay, and this time they're behind panels 132 and then also 131. So you have 132 PW, 131 NW. Okay, a little bit on distribution, and then we'll probably touch on a few little things, and then we'll call it, and probably have we're gonna have some knowledge checks for sure, and then we'll get into session 3. Okay, so air conditioning distribution. Obviously, the cabin air distribution system is going to supply conditioned air to the cabin and the cockpit. That's what we're on right now. Session 2 is on cabin and cockpit. And so it's going to be supplying it through the supply ducts that come from the mixer unit. Okay, and enabling all that air to be there for everybody there. So from the mixing unit, the air goes to the cabin zones through the ducts. And there's different diameters of the ducts. And the ducts are installed where? We have them in different places. You've got some that are installed along the under the cabin floor, so along there, left and right. You also have smaller diameter riser ducts, which are connected to the main ducts. Okay, those supply air also through the outlets that are installed below and above the overhead bins. So that's where those are located. So you got some more riser ducts at the rear of the forward passenger doors, and also aft. So those are pretty standard as far as their construction, made out of fiberglass and a silicone laminate. So just so you have an idea there. Okay, so it's coming from that mixer unit. And that is going to be supplying the left-hand side for the captain's station and the feed area, as well as for first officer's station and feed area. And then there's 2 positions in the left-hand ceiling area above the 3rd crew member station where there's going to be conditioned air, being blown there. Okay, so a few things on the other areas. You got lavatories, obviously. So your lavatory galley system, okay, we're talking about your ventilation. Air is going to flow there as well. You have an extraction fan that's located. That one's located after the aft cargo compartment. And so you have basically, these fans are operated electrically, okay, and those are going to be supplying air into those areas. But that air flows into the lavatories through the grills in the door and into the galleys, the same way. And the extraction fan is extracting, so it's going to be removing air from the lavatories and the galleys through a duct, which is installed, above the cabin ceiling. Okay, all that is just going to go through a valve overboard. Okay, outboard. Or excuse me, overboard. All right, and then you also have an emergency ram air inlet. Because remember what I said, what's the backup if, let's say, both air conditioning packs failed? I mentioned that in the overview in session 1, as you have an emergency ram air inlet. Okay, that's going to be supplying fresh air for the mixer unit. That's where that source is going to be coming from. And so the air from the inlet is going to be enough to supply air for the cockpit and the cabin. So let's just say that there's an emergency. Okay, let's just say that while the pilot's flying, there's, but neither one of the air conditioning packs are working. Then he can select the ram air push button switch, and make that happen. And then that can be, switched to be selected. But the only way that's going to operate is if the altitude of the aircraft is less than 10,000 feet. Okay, so it won't be happening above that. And then also the cabin differential pressure has to be less than 1 psi. It's the only way that ram air push button can be selected. So basically you have fresh air that's being pushed into the ram air system, and all that's going to be flowing to the mixer unit. And then obviously going through the supply ducts to the to do the distribution of that air. Okay, and I don't want to repeat what I already covered, but air conditioning bite tests. I remember I said there's 3 different kinds. So those are just a reminder though. You got your power up test, you got a continuous monitoring, and you got system test. Okay, and that will be on the test, by the way. So we'll do a review. Don't panic. But I did mention that before. Okay, so. And there's some, there's some diagrams and pictures to show you what it looks like on the screen. As far as your leg reports. Okay. All right. So that covers session 2. I was talking about the cockpit and cabin. That's what, what's controlling the conditioned air into those areas. Okay, it's going to be your zone controller, and of course you got your pack controllers, one for each air conditioning pack. And what's happening, what do these packs look like? What comprises the pack? Okay, that's all the different components that I just covered, with your condenser, your water extractor, your primary main heat exchanger, right? Your air cycle machine's really big. Main component on the air cycle machine is going to be that shaft where you have your compressor on there. Okay, mainly. So, giving you just an idea when it comes to the components with that, being able to supply air to that cabin in the cockpit. So we're going to go over some knowledge checks, and then we are going to move into session 3, which will be looking at the avionics equipment ventilation, because it gets, there's a lot of heat generated in the avionics compartment. with all that equipment in there. So, we want to make sure we have some ventilation, that's some air that's going in there that's cooler than the temperature that's in there that's generated. So we'll get into that in session 3. So with the cabin pressurization, we have, of course, controllers again. These are the computers. There are 2 cabin pressure controllers. They are located in the avionics compartment and are on shelves 95 VU and 96 VU on the main rack 90. So those are those 2 that are going to be controlling pressurization and monitoring. Just some of the functions that are involved with these controllers. They have alarm functions. Okay, those are your ECAM warnings. There's a self-monitoring. Remember, a lot of these computers, most of them, if I can say all of them, probably have this self-monitoring and being able to do the bite tests. Also looking for any kind of indication of faults. They also have cabin pressure sensors, the air bus interface to the SDAC, okay, on the ECAM. Discrete interface to the landing gear CIU, also with interface with the other CPC, the cabin pressure controller, and then interface with the outflow valve actuator. Okay, the CPCs, okay, cabin pressure controllers, functions have to do with just an automatic cabin pressure control, and again, backup indication for manual control as well. So these controllers are going to be receiving signals from different places in order to monitor and maintain a certain pressurization in the cabin. Okay. All right. So just so you know, those are the 2, and of course we have there's safety valves along with this part of what we're talking about on the pressurization. So there are 2 safety valves that are installed in the aft pressured bulkhead to prevent, of course, too much either way, either positive or negative pressure in the fuselage, in case there's some kind of malfunction with the control system. So those safety valves are there. As you know, we always have safety valves, in case we have a failure somewhere. So we have that. And then there's also a negative delta P check valve that opens if the external pressure is higher than the internal pressure. Okay, there's your delta P check valve. And again, these safety valves are mounted on the aft pressure bulkhead, and they're accessed in the rear galley and by removing an access panel back there. Outflow valve is part of pressurization, so you do have an outflow valve that's motor driven, and it has 2 motors. It has 2 automatic motors, has a manual motor, the gearbox, of course, the valve body, and also 2 electronic boxes. Okay, those are the components of the outflow valve. Okay, the outflow valve is located at the rear fuselage below the right rear cabin access door. So if you need to access that from the you're going to access it from the aft cargo compartment through an access panel there. All right. You do have feedback module as well. The feedback module is a rotary variable transformer that's going to send position data to the controllers through the outflow valve electronic boxes. That's what those are there for. Okay, so that information is going to the cabin pressure controllers. You also have the gearbox, and I mentioned that. Gearbox is going to transfer that movement from the activated motor to the outflow valve flap. You do have faults and indications regarding the pressurization, obviously. So, you've got the power controller power-up test. Like I mentioned before about with the zone controller, you've got a power-up test. Well, you have the same thing here with cabin pressure controllers. There's a power-up test. So, if the aircraft is on the ground and engines are below the minimum takeoff power, and also if the power-up test is done after a cold start, okay, and a reset or a power supply interrupt. Okay, so we have kind of similar conditions as last time when we talk about power-up test. So here, what can you expect? You've got the duration of the power up test here in this particular case is 1 second. And during that time, remember what I said, it's going to be checking hardware and software just like in the zone controller. So it's going to initialize all of that. Okay, so let's say the test passes, everything's fine. Then the press page is going to show a normal display. If there's something wrong, then the warnings are going to be in that upper part of the ECAM and, you know, whatever indications there as far as the faults. All right. Of course, you do have your built-in test equipment, and that's just going to be continue to monitor things. You've got a last leg report on the MIG-DO, previous leg report, pretty standard, as we've seen before with some of the other indications. Okay, just to give you an idea on some more of these pressurization system fault and indications, you've got a test calibration line key is when you have that depressed. The MIG-DO is going to show different things. One of them is going to be like the ADARUs 1, 2, 3, your LFES, okay, ground air supply, ESC packs, and your mode select. You also will see your class 3 faults on there. Okay. All right. So that's what we have on the as far as the control of the pressurization, and just kind of go over a little bit more on the pressurization of the cabin. There are interfaces, so I just want you to kind of hear it verbally so you can have some familiarity with them. But you do have ADARUs, your FMGS, and your EIU interface, along with your landing gear CIU. So you have those giving discrete signals for the flight ground status that's going to be sent to the cabin pressure controllers. So those are your interfaces that you have. And of course the monitoring system, you know, we have that. There's different modes. I'll get into pressure schedules in a little bit. I just wanted to kind of cover the monitoring system. The monitoring system, just so you know, the abbreviation is CPCS. Okay, CPCS is Cabin Pressure Control and Monitoring System. And of course, that whole system is making sure that that pressure is where it needs to be, regardless of the attitude of the aircraft. So it's automatically controlling the quantity of air that's going in there and out through the outflow valve. There's also a manual system which controls the CPCS in case that the automatic system's not active. And you have your safety valves as well. Okay, so automatic operation, you know, there's really no need for any intervention there. But there is an opportunity to be in a manual operation. So you have that toggle switch that controls the manual motor of the outflow valve. And that's selected by the pilot in the cockpit with the man cell push button switch. Okay, selected to MAN for manual. So that's possible there. Of course, you know, so now we got pressure schedules. There's different modes. You've got cruise mode, descent mode, right? These are all just kind of different modes that the plane can be in, and what needs to happen in order to maintain the pressurization. So you have climb mode, takeoff mode, your ground mode, abort mode. Okay, and the other two I mentioned, the cruise and descent, and your control. There's, you know, the control mode logic, so you know what we're talking about, all these things. GN's your ground mode, TO's takeoff, AB's abort, CI's climb, CR's cruise, DI's descent. Okay, so these pressure schedules are going to be working with a dedicated rate limit, again, to make sure that the pressurization is being maintained for the comfort of everybody in the, you know, in the cabin and cockpit. Okay, so all right, so that's on cabin pressurization. Okay, so let's now go into some knowledge checks, and hopefully this will help you tremendously with passing the test. Okay, so these knowledge checks are going to be on session 2, which is cabin and cockpit cooling heating, and I just went over pressurization and the computers involved with that. the controllers. Okay, so this is question number 20, but one of the main components of the air conditioning packs is, okay, your two choices are condenser or high pressure water cooler. Okay, the answer is the first one, condenser. Okay, the next question. When the pack controllers are in charge, it limits the water extractor outlet temperature to what temperature? Okay, just take notes on this one. I probably didn't mention it, but this one is 20 degrees Celsius for pack 1. Okay, is one choice, and 10 degrees Celsius for pack 2. Okay, that's option A, or choice A. Choice B is 30 degrees Celsius for pack 1 and 40 degrees Celsius for pack 2. Okay, so let me just say the question again. When the pack controllers are in charge, it limits the water extractor outlet temperature to what temperature? Okay, so that answer is actually the first one. Okay, 20 degrees Celsius for pack 1, and it limits that outlet temperature for pack 2 to 10 degrees Celsius. All right, next question. The zone controller's secondary computer operates at the same level of system parameters as the primary computer. Is that true or false? Okay, the answer is false. Remember, I gave you a kind of a random idea of what the secondary computer doesn't do, but the primary computer does. Okay, so that's the answer is false. Okay, next question. The air cycle machines are installed between what two components? Okay, choice A, plenums and condensers, or choice B, plenums and primary heat exchangers. Okay, it's the first one, plenums and condensers. That's where the air cycle machines are located. Okay, the condensers are located between which two components? Okay, choice A, reheaters and mixer unit, or the air cycle machines and the mixer unit. Okay, the answer is B. The condensers are actually between the air cycle machines and the mixer unit. Okay, next question. The water extractor's function is to extract water that has condensed and collected in the air cycle machine or the condensers. Okay, so condensers. Okay, which panels can you access most of the components of the air conditioning packs? Choice A, is it panels 191 and 192, or from panels 131 and 132? Okay, it's the first answer. All right, next question. The air cycle machines have an anti-icing system at the turbine inlet. Is that true or false? Okay, the answer is false. Okay, the answer is that it's at the turbine outlet, not the inlet. Okay, so remember the anti-icing system when it comes to air cycle machines. Remember, air cycle machine is part of the ram air system. Okay, and the turbine of the air cycle machine, okay, that's actually located on the rotating shaft, but at any rate, the answer is that it's at the anti-icing system is located at the outlet, not the inlet. All right, next question. When the air conditioning pack controller fails, what component controls the pack outlet temperature? Okay, choice A, bypass valve, or choice B, anti-ice valve. Okay, it's actually anti-ice valve. Okay, at what temperature should the pack outlet temperature be maintained? Is it choice A, 15 degrees Celsius, or choice B, 25 degrees Celsius? All right, the answer is the first answer, 15 degrees Celsius. All right, so what is the function of the mixing unit? Choice A, mixes conditioned air with ram air, or choice B, mixes conditioned fresh air with reconditioned cabin air. Okay, that's choice B. Okay, I hope you guys hope you have your this in front of you so you can follow along. Okay, next one. What would you find in line with the recirculation ducts? Is it choice A, extraction fans, or choice B, cabin recirculation fans? Okay, well, it's going to be choice B, right? There's recirculation ducts. We're talking about recirculation, so it's going to be cabin recirculation fans, right? All right, next question. The mixer unit has two sections to it. What are they? Okay, choice A, the mixer chamber and the distribution head, or the mixer zone and the supply port. All right, the answer is the first one. Okay, next question. What can you find left of the mixer? What's located there? Okay, choice A, the mixer flap valve or the mixer flap actuator. The answer is the latter. It's the actuator. All right, last question for this session. Okay, the CPCS, okay, that stands for Cabin Pressure Control and Monitoring System, ensures that the pressure in the fuselage is safe and comfortable for everyone in the cabin and cockpit. Is that true or false? Okay, the answer is true. That's a true statement. All right, so that gives you an idea with the questions. I suggest you take notes and you get to replay this so you get the answers right here. This is important because you're probably going to see most of these here, on the test. All right. Okay, we're going to be moving on to our next session. This is session 3 on the air conditioning system for the Airbus A320 family. And so on session 3, we are now on to the cooling of the avionics equipment and the avionics compartment. So what do we have here but another computer? So with the way it's going to be laid out, I'm going to talk about the computer a little bit and then go over what the components are for this ventilation system for the avionics equipment, and then talk about circuits, because there's different ways and configurations that the cooling happens there. So, and then we'll have the knowledge checks after that. All right, so let's start with the brains behind the ventilation system, and that would be the computer. The abbreviation is AEVC, which is abbreviated for Avionics Equipment Ventilation Computer, and that automatically controls the ventilation system, being able to manipulate the proper configuration depending on the conditions of the plane, in flight or if it's on the ground. This is in relation also to the aircraft skin temperature. So just those different variables are playing a part in basically what the computer is going to do and being able to control that cooling. So of course we're going to talk about the components, which we're going to have fans, valves, pressure switches, and temperature sensors involved. And then as far as our interfaces, we have the landing gear control and interface unit, and so that'll be a part of it, and also the cabin pressure controller. So those are the computers where information is going to be sent from there to the avionics equipment ventilation computer. Okay, so where's this piece located? Where's this computer located? This AEVC is located on the 88 VU shelf in the rack 80 VU in the avionics compartment, and so that's where that's located. Now, as far as a listing of components that you should be familiar with, there's an extract fan, a blower fan. We've got the different valves that I just mentioned. So we have a skin air inlet valve, and we have also the bypass valves. So we have a skin air inlet and outlet valve, and then we have the bypass valves. So you have skin exchanger, inlet, bypass valve, as well as your outlet bypass valve. Okay, so there's also a filter assembly, smoke detector as well. All right, and we also have our duct temperature sensor. Okay, pressure switches. There's an isolation valve. This is a skin exchanger isolation valve, as well as a conditioned air inlet valve. Okay, and of course the heat exchanger itself. All right. So those are the components. I just listed them for you so you can have just a verbal familiarity with the different valves that are involved here, and the sensors as well, and pressure switches, the smoke detector. So let's kind of go over a little bit before I talk about circuits, because I want you to get an understanding a little bit better with the specific valves that we're talking about. So just real quickly on the fans, and then I'll go into the valves. The blower fan, there's a blower fan and an extract fan. The blower fan is secured with clamps to the brackets on the aircraft structure. This is going to be in the avionics compartment, and it's powered by a motor, okay, that's going to drive a fan wheel, which has the blades. It's going to run continually at a rate of 11,600 RPM. So that's what that's running at. There's also a thermo switch and relay that's installed on the stator of the blower fan. So if the temperature of the stator gets to 284 degrees Fahrenheit, that switch is going to isolate the electrical supply to the fan. Also, a fault indication light and reset button are there as well in the fan body. Okay, as far as the blower fan's location, that is in the avionics compartment, and you can access that through door 824. Now, what about the extract fan? Extract fan is identical, it's to the blower fan, but I always caution when I share information is, always pay attention to the part numbers. Make sure that you're switching exactly what it should be, not just that, gee, they look alike, okay? But do pay attention to part numbers, making sure you're doing the right replacement if you needed to do that. Okay, so there's an extract fan that's also located in there in the avionics compartment. Okay, so now what about the valves? We have a skin air inlet and an outlet valve. These are both installed in the fuselage skin at the forward lower left or right, so left and right hand side. So for your skin air inlet valve, that's located at the forward lower left hand side, and then your outlet is located on the right hand side. Okay, but they're both, in the fuselage skin at the forward lower part. Okay, and there's the valves are electrically operated. They're the same type of valve, as far as configuration of it. They're both a single flap type. And so, what's the condition of it, or position, I should say? What's the position of the valve when the aircraft's on the ground or when the aircraft is in flight? Okay, so let's just take the inlet valve. If the aircraft is on the ground, the valve is open. Where we have the outlet valve, when the aircraft is on the ground, the valve is fully open as well. Okay, so we have a nice parallel. If the airplane is in flight, okay, then that valve is going to be fully closed. Okay, whether it's the inlet or the outlet valve, they'll be closed when that aircraft is in flight. Okay, now on the ground, after the takeoff sequence signal, the valve's not going to close. Okay, valve is not closed. The crew's going to just have to manually close it. Okay, now here's some degrees. These are thresholds. When the skin temperature is above 93.2 degrees Fahrenheit, okay, there's a smaller flap that's going to open during flight when you have that condition. The other condition is if smoke is detected in the avionics ventilation system, then that flap is going to open. All right. Okay, so that's your skin air inlet and outlet valve. Just so you know what their conditions are, or positions. When the aircraft is on the ground, it's fully open. When it's in flight, it's fully closed. Okay, so what about skin exchanger inlet bypass valves? So now we have inlet and outlet bypass valves. These are the skin exchanger bypass valves. And so what is it doing? What is it supposed to be doing? It's going to be discharging any excess air. It's going to discharge it to the forward cargo underfloor area. So that's what it does. Okay, and that's the inlet bypass valve that's gonna, do that. Okay, so with that, it's a butterfly type. Just so you know, there's 2 micro switches signal that are going to signal the valve position to that avionics ventilation computer, and the valve, so you know, location that is located under panel 128EG in the avionics compartment. It's like the forward part of it. And the outlet bypass valve, what's its job? Okay, it's going to let air into the system when this skin heat exchanger efficiency is degraded. So when you don't have that operating at optimal, that outlet bypass valve is going to allow air into the avionics compartment. The location of the skin exchanger outlet bypass valve is in the forward left-hand side of the avionics compartment, and both of them are accessible through the same door, just so you know. These are downstream, just so you know, right? Outlet bypass valve are downstream of the skin heat exchanger, which I'll get into talking about in a little bit. But that gives you an idea with the skin exchanger inlet and outlet bypass valves. Okay, you also have a filter assembly. You've got a smoke detector. The filter assembly is also accessible through the same door. So basically all of these components that I'm describing to you can be accessed through that door, 824, that goes into the avionics compartment. There's a smoke detector. If you know very well, if you're with smoke detectors, don't mess with them. Just, obviously if there's something wrong with them, they need to be replaced, but that's going to be through or if they're going to need to be looked at or whatever, that's going to be needed, that's going to be done by a company who have technicians who specialize in dealing with smoke detectors for here. And then we also have temperature sensors, of course. The duct temperature sensor we have here is upstream of the electronics rack 80 VU, and there's set temperatures, okay, for these sensors, right? So with the duct temperature sensor, we've got the values of increasing temperatures 143.6 degrees Fahrenheit or decreasing temperatures 140 degrees Fahrenheit. Okay. There's also pressure switches, which are part of their in the avionics ventilation system. There's 3 of them. You've got, because I'm going to talk about circuits. So I'm going to mention 2 switches, and there'll be 1 switch. These are the pressure switches. There's 2 in the blowing system and 1 in the extraction system. Remember I said there's the blower fan and you've got an extract fan, excuse me. So we got pressure switches are going to be playing a part in this. So 2 in the blowing system and 1 in the extraction system. Okay, so when there's, for example, what's the threshold with these pressure switches? You've got a low flow indication. Okay, so what is that defined as? Our low flow indication is going to be a differential pressure of 1.7 millibar plus 1.3 or minus 0.5 millibar. Okay, the pressure switches, those are installed in the cooling ducts. Okay, and they're going to be, again, sending signals. When it's low, it's going to be giving or affecting what's going to show on the display. So it's going to give a warning message, because all these signals are going to the computer, and then that's going to be sending the signals to the cockpit with the warning messages of vent blower fault, which is one of them, or if it's an extract issue, it's going to be vent extract fault. And this is all when there's a decreasing pressure airflow that's detected by those switches. Okay. All right. So then we've got the actual skin heat exchanger, and this is located in the upper fuselage between frames 12 and 14. And what is this for? See, heat exchangers cool things, right? So it's going to cool that air in just regular operations. Okay. You can access this one through removing a panel near the lavatory A and the galley unit at location 1 if you needed to access that. There's also the skin temperature sensor. Okay, that's inside of the fuselage skin. Okay, I mentioned that earlier, but the skin heat exchangers is what I wanted to share with you a little bit, where you can access it. Okay. All right. So with the skin heat exchanger, what else do we have? We have an isolation valve. This is the skin exchanger isolation valve. And this is installed upstream of the skin heat exchanger I just described to you. So let's say the airplane's on the ground. And two things. Number one, airplane's on the ground. And number two, the skin temperature is above 12 degrees Celsius. Okay, those two conditions present, that means that the skin exchanger isolation valve is closed. Okay. And so when we have that closing of the isolation valve, then we're going to have air from the extract fan be able to be discharged outside the aircraft through the extract valve. So we have an extract valve too, and that's what under those conditions that we'll have that go out. Okay. There's also a conditioned air inlet valve that's actually installed in the main supply duct for the cockpit. Okay, so the cockpit supply air, okay, this is different. I'm going to talk about the circuits in a bit, but you know, one of the sources or ways that you can cool the equipment is through the cockpit supply air into the system. And that only happens if there's a failure of the blower fan, the extract fan, or the computer, okay, itself. I mean, that's when you're going to have that happen. Or if there's some kind of, if there's smoke detected, then that's when we're going to have the cockpit supplying, the air coming from the cockpit to be supplying the cooling and ventilation for the equipment. Okay, so that's one way. So let's kind of go over the circuits. This is going to be, you know, describing, you know, what conditions do we have certain configurations as far as being able to cool that equipment. So one of them I just mentioned is the cockpit supply air. Okay, that's definitely one. And then we have three other conditions, or I should say configurations. We have the closed circuit, we have an open circuit, and we have a partially open circuit. Okay, so closed circuit. So let's just go with the closed circuit. Okay, so we have a closed circuit. What does that mean? Okay, how are we defining closed circuit? The closed circuit, okay, means the airplane's on the ground and the skin temperature is below 48.2 degrees Fahrenheit. Okay, so there's two things. Number one, if aircraft's on the ground and the skin temperature is below 48.2 degrees Fahrenheit, or if the plane's in flight, then and the skin temperature is below 87.8 degrees Fahrenheit, then we have a closed circuit situation. So what does that mean? You know what, we're going to involve valves. And so certain valves are going to close, some are going to open. The question is which ones will be closing in this closed circuit. So with these conditions, the skin air inlet and outlet valves are going to close. If those are closing, what's going to open? It's going to be the bypass valve. Okay, this is the outlet bypass valve. So this is the skin exchanger outlet bypass valve that opens under the two conditions I just mentioned. Okay, so remember, bypass and isolation kind of go together. So remember, the bypass valve and the isolation valve will both open under the closed circuit situation. Okay, and then we have an operation of the skin heat exchanger. The three pressure switches I mentioned earlier, remember I said, okay, these are pressure switches detecting a decreasing pressure or airflow. So, you know, we've got with the vent blower fault, there's the two pressure switches are involved that they're detecting and sending that information to the ventilation computer. and that's going to give a warning message of vent blower fault on the display. And then there's one pressure switch that if it's detecting that decreasing pressure or airflow, then it's going to send that signal again to the ventilation computer, and then the message here, the warning message, is vent extract fault. Okay, that'll show up there. So what happens at that time when that's happening, what's the pilot going to do? Okay, there's different buttons, push buttons that we're going to be involved in here. There's the override. Okay, so OVRD, you've got override blower, extract, override blower, override extract, push button, and then you have for both. And so, pushing any of those buttons is going to close the inlet bypass valve, the skin exchanger inlet bypass valve. Okay, so remember I said earlier what opens? The outlet bypass valve. I don't want you to get confused, but I'm just trying to make it clear that we're talking about an air inlet, skin air outlet. Okay, so those close automatically in a closed circuit. Then there's the skin exchanger outlet bypass, that valve that opens, okay, as well as the isolation valve. But then what happens when the pilot pushes these buttons? Now I'm talking about the inlet bypass valve, not the outlet. But the inlet bypass valve is going to open, because normally it would be closed. And so now it's open, because of these switches giving those messages, for that condition. Okay, so that's closed circuit. What about what happens in a partially open circuit? Okay, so with here, how is the avionics equipment going to be cooled in a partially open circuit? Okay, so we have a condition here. And this is whether the aircraft is in flight or if it's on the ground. But the skin temperature, if the skin temperature is above 95 degrees Fahrenheit, then we have a partially open circuit going on. Okay, so that means that you're going to have a partially open skin air outlet valve. Okay, it won't be partially, or it won't be fully open, fully closed. It's going to be full. It's going to be partially open, and then you're going to have the skin exchanger outlet bypass valve open, just like you would have, in the closed circuit. Okay, so that's going to be open, as well as the inlet bypass valve will open. So it's, that's going to open automatically. Okay, and again, the whole idea here is just allowing that cool air to enter that area, okay, in the avionics compartment. Okay, last type of configuration where we can have cooling and ventilation is an open circuit. So this is going to take ambient air when the aircraft's on the ground, and also when the skin temperature is above 53.6 degrees. That's when it triggers, and now we have ambient air being drawn through the skin air inlet valve, going through the check valve and the filter assembly. Okay, and so that blower fan is going to suck it in and go through the check valve before cooling the equipment. Okay, so the air, of course, after going through the equipment, is going to be extracted and be kicked overboard, okay, through the outlet valve. So that's the open circuit situation, and we're dealing with ambient air in that scenario. Okay, so all right, so it kind of gives you a good idea, I think, of understanding what the components are involved with the ventilation system for the avionics equipment, and then the three different circuits that we can have depending on some conditions, because conditions are related to the temperature and pressure, whether or not the aircraft's on the ground or if it's in flight, all those different variables and that coming together. So, and of course you have the computer, the brains of the operation there to ensure that's all happening. Just a kind of a quick note with the computer. We have pressure switches. I mentioned there's 3 switches, and then of course you have temperature sensors. Those are all, the information going to the AEVC, okay, the ventilation computer. But you also have information coming from the cabin pressure controller, your CPC, and your landing gear control and interface unit. So Just so you know, there's those other sources for input into the ventilation computer. Okay. So I hope that gives you a good idea of ventilation components, and the valves that are involved. Okay, where they're located. Okay, remember, skin outlet valves, skin inlet valves they're in the fuselage skin, like I described earlier. Okay, so all right, so we're going to go ahead and do some knowledge checks, and then we will be, we'll finish out with our final session. Okay, so what kind of questions could you come across on the test? All right, so let's see. The ventilation system for the avionics compartment is controlled by the AEVC, the Avionics Equipment Ventilation Computer. Is that true or false? That's true. Okay, what are the inputs for the AEVC? Okay, choice A, signals from the cabin pressure controller and landing gear CIU, or signals from the zone controller and pack controllers. Okay, so first answer. Okay, where is the AEVC located? Okay, there's choice A, a 96 VU shelf or the 88 VU shelf. Okay, that's located on the 88 VU shelf. What are the different ways that the avionics equipment can be cooled? Choice A, closed circuit, open circuit, and independent, or closed circuit, open circuit, partially open circuit, and cockpit supply air. Okay, so it's the latter. In a closed circuit, the avionics equipment is cooled when the skin temperature is below what temperature when the plane is on the ground? Choice A, 48.2 degrees Fahrenheit or 90.7 degrees Fahrenheit. Okay, it's actually the first answer, 48.2. All right, in a closed circuit, in a closed circuit, the avionics equipment is cooled when the skin temperature is below what temperature when the plane is in flight? Okay, is it 87.8 degrees Fahrenheit or 48.2 degrees Fahrenheit? Okay, the answer is the first one, 87.8. Okay. All right, which valves close in the closed circuit cooling system? Okay, choice A, skin exchanger outlet bypass valves or skin air inlet and outlet valves. Okay, so it's the latter, the skin air inlet and outlet valves. All right, next one, what causes the warning messages, okay, which are vent blower fault or vent extract fault, to display? Okay, choice A, decreasing pressure or airflow or increasing pressure airflow. Okay, it's going to be the first one I mentioned, right? Decreasing. Which valve closes automatically after the pilot pushes any of the override blower or extract push buttons? Choice A, skin exchanger outlet bypass valve or skin exchanger inlet bypass valve. Okay, that would be the latter. Remember, it's the skin exchanger inlet bypass valve that closes automatically when the pilot takes that action. Okay, when the skin temperature is above 95 degrees Fahrenheit, the avionics equipment is cooled in which kind of circuit? The open circuit or the partially open circuit? Okay, that's going to be the latter. It's going to be in a partially open circuit. Okay, after the equipment is cooled by the air in a partially open circuit, the air is moved overboard by which valve? Is it the skin air outlet valve or the skin exchanger outlet bypass valve? Okay, the answer is the first answer. It's skin air outlet valve. Okay. When the skin temperature drops below 87.8 degrees Fahrenheit, which circuit is the cooling system in at that point? Is it in a closed circuit or open circuit? When it drops below. Okay, it's in a closed circuit. All right, one more question. All right, when does the cockpit supply air get used for cooling the avionics equipment? Is it A, skin temperature is above 100 degrees Fahrenheit, or answer B, there exists a low flow? Okay, the answer is the second answer. Basically, when there's a fault, when things fail, that's when the cockpit supply air is going to be used. Okay, so I hope that gives you a really good idea. In fact, just definitely circle the answers and commit some of this thing to memory. But I hope that gives you a better understanding of, of the skin, involved as one of the variables with the ventilation system for the avionics equipment. Okay. All right, so we will be proceeding on to our final session, which will cover. This is session 4 of air conditioning for the Airbus A320 family. This is our final session for the air conditioning part, and then we're going to cover some knowledge checks, but this will definitely complete the air conditioning. Okay, so the last thing that we need to cover is the aft cargo compartment. And what we're talking about here is the ventilation and heating and just the cooling, okay, of the aft cargo compartment. So, of course, you have a heating controller. That's for starters, and then I'll talk about the other components. But you do have the heating controller that's obviously going to be regulating the temperature in that compartment. And there's pre-selected values for that, so it maintains, based on those, those preset temperatures. The temperature selector, which the pilot can control, this is in the cockpit and the overhead 22 VU. Now, of course, where's the data coming from? For coming into the heating controller, so that it can actually keep that and maintain the preset values. That would be temperature sensors. Those are located in different places. In particular, there's temperature sensors. There's the duct temperature sensor, which is located at the inlet duct. So this may be a test question. Okay, there's temperature sensors. There's a duct temperature sensor and the cargo compartment temperature sensor. And so the duct temperature sensor is actually at the inlet duct, and the compartment temperature sensor is at the extraction duct. So that's the difference right there. You also have, besides temperature sensors, we also have valves, of course. So we do have a pressure regulating valve, and obviously that's going to be controlling the hot trim air supply. Remember I mentioned about 4 psi above cabin pressure, so the pressure regulating valve is going to be used to control that pressure to supply, to keep that 4 psi above cabin pressure. You also have, of course, we talked about the trim air valve before, but we have the trim air valve that's located under the body fairing, and you can make sure you check with your MRO as far as different panels, because it could vary a little bit depending on some things. There could be a different configuration. Okay, so that's what you have. You have the temperature sensors. Okay, you have the selector obviously in the cockpit at 22 VU panel, and your valves. Okay, so just a little bit isolation valve. That's actually, you can get access to that in the aft cargo compartment, and there's 2 of them. There's the forward one under panel 151EW, and the other one, the aft isolation valve, under another panel. So you have those. There's also the extraction fan that you can access also under same panel as where the aft isolation valve is located. Okay. So you have that, and the whole idea here is being able to draw in air, and being able to have, once it's gone through the cargo compartment, to be able to have it, basically, get out. So So we have the heating. So with the heating, I mean, we're still dealing with bleed air, but the bleed air is going to actually come from the APU, and it's going to take that bleed air from the APU and it's going to mix it with cabin air, and then that gets sent, basically becomes the ventilation system for the aft cargo compartment. The hot bleed air is going to go through a pressure regulating valve, like I just mentioned, the pressure regulating valve, as well as that trim air valve I just talked about. So it's basically going to take all of that air, it's going to mix it with the cabin air before it goes into the cargo compartment. Okay. You also have proximity switches, just to be aware. The proximity switches are at the door of the cargo compartment and also at the bulk cargo compartment doors. So basically what these switches are doing is they're going to stop the movement of the doors. Okay, it's going to inhibit it's going to inhibit the heating system if the doors are open. Okay, so it gets triggered. Okay, so that's pretty much it. Now there is kind of a critical point, and I'm talking about temperature, in particular duct temperature. So we don't have an overheating of the area. The duct temperature, if it goes above 190.4 degrees Fahrenheit, then the fault light is going to come on the hot air switch. Okay, and of course when that happens, just standard procedure is the pressure regulating valve is going to close. So it's an overheat condition, right? So now if the way that it's going to not show, is going to not be illuminated as far as the fault, is when the temperature drops. So if it gets past 190.4 degrees, fault light's going to come on the hot air switch, and it would have to drop down to 158 degrees Fahrenheit before the system can be reset. Okay, and the way that that system's reset is just by pushing that hot air switch button, just pushing it twice. Okay, so there's really not much to it. I just mentioned you're still going to have controllers, right? So you have a heating controller for the aft cargo compartment for the heating part, using the hot bleed air, the trim air, and then you got your isolation valve, your extraction fan. Okay, so that's pretty much it. And of course there's diagrams that help you just see what they look like, but if you've seen fans before, it's pretty much fan's a fan. Alright, so let's go ahead and start with some knowledge checks, and we'll just finish this out. And just one thing I wanted to mention to you, as far as the ventilation air, I just mentioned about cabin air, right? So that's where that's coming from, as far as the source of air for cooling and heating the aft air cargo compartment. Okay, so question number 1, where does the ventilation air come from for the aft cargo compartment cooling? Okay, is it the cabin zones or the cockpit area? Alright, I just mentioned it was the cabin. Okay, so with cabin zones. Alright, where does the air come from for the aft compartment heating? Okay, option A, it's cabin air mixed with cockpit air, or is it hot bleed air mixed with cabin air? It's the latter, right? Okay, hot bleed air goes through the extraction fan and isolation valve located in the distribution ducts. Is that true or false? Okay, that's false. Alright, the ventilation air goes through the pressure regulating valve and trim air valve before it gets distributed. Is that true or false? Okay, that's false. Yeah, so it's actually the other way around. Okay, when we talk about hot bleed air going through the extraction fan, it's the ventilation air that goes through the extraction fan and isolation valve. Alright, so next question. The proximity switches are part of the aft cargo compartment heating system. Is that true or false? Okay, it's true. I mean, it's part of it in the sense that it works in conjunction, that they're at the doors, and if the doors are open, then the heating system's going to be affected. In other words, it's going to be shut down. Okay, So when does the fault light on the hot air push button switch come on? Is it when the duct temperature goes past 190.4 degrees Fahrenheit, or when the ambient air in the cargo compartment goes past 190.4 degrees Fahrenheit? Okay, it's the first choice, right? The duct temperature is what we're interested in. Okay, where are the isolation valves located? The forward isolation valve is located under panel 151 EW, and aft isolation valve under 162 DW, excuse me. Or second choice, forward isolation valve is located under panel 131 VW, and aft isolation valve under panel 162 VW. Okay, it's the former. Okay, you're not going to find the isolation valve under panel 131 anything. It's actually 151 or 162. Okay. All right, so under which panel is the extraction fan accessed? Okay, is it 161 or 162? I know they're close together, but it's actually 162. All right, the aft cargo compartment temperature selector is located on which panel in the cockpit? Is it on 30 VU or the 22 VU panel? Okay, I mentioned that's 22 VU. Okay, in the event of heating controller failure, okay, I didn't cover this right now, but this is one thing you can be aware of. And you already know about class 1, 2, 3 failures, but here, in the event of heating controller failure, give an example of a class 1 failure that will show up on the ECAM page. Okay, here's your two choices. Okay, choice number 1, aft cargo duct overheat. Okay, that's OVHT, by the way. Or aft pressure, without the E, reg valve temp. Okay, the answer is the first one. Class 1 failure is aft cargo duct overheat. Okay, all right, where is the duct temperature sensor installed? Is it at the extraction duct or the inlet duct? Okay, so inlet, remember I just made a great distinction between the duct temperature sensor and the location of the compartment temperature sensor. Okay, so the duct temperature sensor is at the inlet duct. Okay, next question. In the event of heating controller failure, give an example of a class 3 failure that may show up on the ECAM page. Okay, so your first choice is aft cargo heat CONT, okay, for controller, or aft TA PRV shutoff relay. Okay, so a class 3 failure is actually the first one. It's aft cargo heat CONT, okay, for controller. The other one that the second choice, which is actually the wrong answer, is a class 2 failure. Okay, the TA PRV shutoff relay. All right, last knowledge check. Where is the heating controller located and how can you access it? All right, so 92 VU in the avionics compartment and door 824, or 96 VU in the avionics compartment and door 811. Okay, it's actually the last choice. It's 96 VU in the avionics compartment. Okay, and door 811. Okay, that's the heating controller for the aft cargo compartment heating system. Okay, so that gives you an idea, more than an idea, of what kinds of questions you're going to find. Hopefully you wrote these things down because you're more than likely going to see them again. All right, so this concludes that. If you have any questions, of course, you know we have Rick and also another individual with us who's an aircraft maintenance technician who can answer your questions. His name's Ken. So we appreciate your participating in this instruction.